So the second part of the lesson, we're going to talk about given a point and a line, and we have to determine, come up with an equation that is either parallel or perpendicular to the line that we're given. So in the two examples on the handout that Mrs. Pittman is going to pass out to you, we're going to talk about these examples. So example number 1 and example 2, we're given a point and it has to be parallel to a line that's given. Okay, so in this first example is parallel, last two examples is perpendicular. So the first thing we're going to figure out is, read the question carefully. Passes through the point -2 and 7 and it's parallel to the line y equals negative 4x plus 1. So from here, the thing that you have to remember is, just by the slope-intercept equation for the line that we need to find that's parallel to, my slope is negative 4. So that means we're going to use this information, and we also know a point. We can come up with an equation based off on the fact that we have a point slope form. So plug in my point, because it has to go through this point, right? And my slope. So y is equal to negative y minus 7 from here is equal to negative 4 times x minus 2. Okay? Remember, my point slope equation is given by y minus y1 is equal to m, x minus x1. Okay? So that's the equation, but now we want to write it in slope-intercept form. So that means rearranging. So distribute the negative 4 and plus 7 over, you end up with y is equal to negative 4x minus 1. Okay, the second example, we want to find the equation of a line that passes through 3, negative 1, and it's parallel to the line x minus 3y equals 9. Okay, so it's again, given a point, given a line. So this line, the equation that we're given, it's not in slope-intercept form, so we want to rewrite it in slope-intercept form, so we know what the slope is. So first step, that's what we did. We write this in terms of x, so 3y is equal to x minus 9, and divide everything by 3, we get y is equal to negative 1/3 x minus 3. That means my slope has to be 1/3. Now remember, we're given a point and we know the slope, we can write it in point slope form. So y plus 1 is equal to 1/3 times x minus 3 is equal to y is equal to 1/3 minus 1 minus 1. Just by rearranging this equation, we get y is equal to 1/3 x minus 2. So that's my line, well that's my equation that will be parallel to this line and passes through 3, negative 1. Now the last two examples, we're given that a point, and then we need to make sure that line that we're finding is perpendicular to y is equal to 2x minus 4. So again, we're given a slope-intercept form of the equation of the line that we need to be perpendicular to. So because we need to be perpendicular, we need to figure out what the slope is. So if it's parallel, my slope is 2. But if it's perpendicular, it's going to be the negative reciprocal. So in that case, divide this 1 divided by 2 and then multiply by negative 1. And that's what we have. My perpendicular slope is negative 1/2. So again, given a point and a slope, we can write our equation in point slope form. Y minus 3 is equal to negative 1/2 x minus 4. And that's my equation. So that means y is equal to negative 1/2 x plus 5 by rearranging the equation. Last but not least, passes through negative 5, 1 and is perpendicular to 5x plus 3y is equal to negative 21. So again, rearrange this equation so it's in slope-intercept form. So after doing that, we find that this line can be written as y is equal to negative 7 minus 5/3 x. That means my slope here for this line is negative 5/3. So if I want to be perpendicular, it's going to be it's going to be a negative reciprocal. So negative reciprocal is going to be positive 3/5. So again, we have a point and we have a slope. We can write it in point slope form. So y minus 1 is equal to 3/5, because that's a perpendicular slope, multiplied by x plus 5. Okay, so x minus 5, which is x plus 5. So by rearranging, we get y is equal to 3/5x plus 4. Okay, now spend some time working through the examples on the back of this handout, and then take a break. Okay, that's all.